Now, in this lesson, they're going to go backwards and they're going to give you this, and you have to find this. So if they tell you that a quadratic equation has -2 and 3 as solutions, as roots.
No, it's possible.
What's the question?
No, we're talking about that.
No.
Yes, I know, but what's the question?
No, it's because he was asking wouldn't the 3 be negative instead of the 7, but if you pass the 3 to the other side, it makes it positive.
So you're good? Okay, so they tell you that these are the roots, and they tell you to find the quadratic equation of which these two are the roots. What would you do? What comes to your mind?
X. No, X plus 2 because it's on the other side.
You immediately think this is x plus 2.
X minus 3 equals 0.
And that
equals 0.
equals 0. So what would the quadratic equation be?
X squared
Plus. No,
minus
x.
x
Minus 6.
minus 6
Very good. And that's it.
equals 0.
It's very easy, right? It gets a little harder when...
Fractions.
Where's my thing? Here it is. Well, if it's fractions, you do the same exact thing, right?
But it's just like...
You want to do one with a fraction?
Sure.
Just to see? X equals -3/5 and 1/2. What would you do?
X plus 3
times
minus 1/2.
It's exactly the same thing. And then you multiply.
x squared.
But it says with a coefficient of 1. What does that... What
With a coefficient of 1 means that these have to be left alone. Otherwise, this would be 5x plus 3. See? That's another way of writing this one. 5x plus 3 and 2x minus 1 equals 0. Right? When you leave these by themselves, you get 3/5. But if you multiply these two, they wouldn't have a coefficient of 1 when you multiply them. They would have a coefficient of 10x squared. And you want it with a coefficient of 1 like that. Does that make sense? Okay? Now, what if they give you something just a little bit longer, like this? The roots are 1 plus square root of 2 and 1 minus the square root of 2. The same exact thing, except you're careful and you put x minus and you open parentheses. The whole thing. 1 plus square root of 2.
So both of them are minus.
Times x minus 1 minus square root of 2.
Plus.
When you use the minus, you make sure, but you're assuring yourselves that the whole thing inside the parentheses is positive when you solve it. So the signs don't change. Does that make sense? So that's why I put it inside parentheses. Otherwise, this minus or this plus here messes with the signs up here. And then you just multiply everything and you get the same exact thing. What kind of math? You good? You don't get it? Do you understand how I got this? Did you understand this part?
Yeah.
It's exactly the same thing. X minus the answer they give me. Here it is.
I got it.
From here on, all you have to do is multiply. Do you want me to go on or you're good?
Okay.
You good? Okay. And then, of course, it doesn't finish here.
Fun.
How would it? That would be way too simple.
Saxon tenía que ser.
Oh, yeah. Then we have overall average rate. Which has absolutely nothing to do with the previous two topics. Overall average rate if we're thinking physics and we're thinking velocity, or speed, not velocity, speed, you would think if a car goes the first 10 miles, it goes at 50 miles per hour, and the next 20 miles, it goes at, I don't know, 60 miles per hour. Your first, and I asked you for the average rate. The first instinct is to add these two and divide it by 2, right? But that would be incorrect. Because the average rate or the average speed of something is the total distance divided by the total time. It is not the first velocity plus the second velocity plus the third velocity divided by 3. Like you would think average is. It's not. It's total distance over total time. Once you understand this, and you always do total distance over total time, you're good. Okay, so let's see, for example,
With that one.
yes, but we don't have time for that one.
Oh.
I mean, we don't have the time that they did it in, so we can't do it that way. But look at example 38.7. Frank and Judy drive for 100 miles at 100 miles per hour. So distance 1 is 100 miles. Oh, we can do that one, actually. Rate 1 is 50 miles per hour. Can we get time 1 if we have distance 1 and rate 1? We can. How do we get it?
Distance divided by rate.
Distance 1 divided by rate 1, right? Which would be 2 hours. Then they drive for 180 miles, so that's distance 2, 180 miles, at 60 miles per hour. That's rate 2, 60 miles per hour. What would their time be? It would be 180 divided by 60, right? Which is 3 hours. Very good. So you want to know their average rate. Remember that the line on top of it is average. So average rate would be
100 plus 180 divided by 2
2 plus 3.
because it's total distance divided by total time, divided by 2 plus 3, for a total of 280 divided by 5. And that gives me an average rate of
Numbers.
56
56
miles per hour.
miles per hour. Which we would never have gotten if we had 80 miles plus 100 miles. In the end, rate and speed is always distance divided by time. So to find the average, it's got to be the total distance over the total time. And that's it. Questions? We're good? Got it?